Jacob's back. Welcome back. Congratulations.
Thank you, Jody.
On the wedding. We missed you, and you have a new series for us.
I do. A lot more exciting news in the coming weeks with this 8-part series about the NCEP centers. Within the National Oceanic and Atmospheric Administration, they have the National Centers for Environmental Prediction. There's 8 of these that we're going to be focusing on over the coming weeks. First, I wanted to start off with weather outside of our atmosphere, space weather. The Space Weather Prediction Center, SWPC, they focus on what happens between the sun and the Earth, and that creates our beautiful northern lights displays, but it also has a lot of impacts on infrastructure and communication systems when there are solar storms coming from the sun towards the Earth. So the SWPC forecasters use instruments on the ground and in space, satellites, to watch the sun for threatening features. When these solar storms happen, they have to issue forecasts and communicate with a wide variety of industries across the globe. They issue watches, warnings, and alerts based on these forecasts. So essentially, the SWPC, which is located in Boulder, Colorado, monitors the sun for impactful space weather to our society. With the aurora, that's just really one component of what they do. There's a 3-day forecast that you can find on their website, but essentially you have the magnetic field around our Earth. When you have an ejection of protons and electrons, plasma from the sun, that interacts with our magnetic field, and some of those particles can enter at our poles to create our beautiful northern lights display. But again, we're really focusing on this coronal mass ejection with ground-based observations, telescopes focused on the sun, and magnometers which monitor Earth's magnetic field. There's also satellites up to 1 million miles away in space, some that also monitor the weather here on Earth. They monitor those particles released from the sun and X-rays. So to explain why those coronal mass ejections are so important to monitor, I talked with Sean Dahl. He's the service coordinator at the Space Weather Prediction Center, which has about 70 employees. They're staffed 24/7 with at least 1 or 2 forecasters there, but more with big events. So Sean is originally from Williston. He went to high school there, and in 1979 in Williston there was a total solar eclipse, and that is what got him interested in space weather. But here he is explaining these coronal mass ejections.
Coronal mass ejections are really a result of localized intense magnetic fields that are on the surface of the sun. As those magnetic fields become stressed out, they instantly reconnect into something less stressful. Sometimes that'll go ahead and release enormous amounts of energy that will pummel back down to the surface of the sun and release a solar flare. And it also may eject solar material, plasma, energetic particles out into space ahead of it as a coronal mass ejection. So what a coronal mass ejection actually is a piece of the sun flinging out into space, billions of tons of a piece of the sun in the form of that plasma, with its embedded strong localized magnetic field being stretched and pulled out into space along with it.
So even though they do have aurora forecast on their website, they're not really in that aurora forecasting business. It's a lot more about the impacts that these coronal mass ejections have on communications and infrastructure here on Earth.
But what we're really doing is supporting infrastructure and technology, customers that operate those things, whether it's the power grid, which can be dramatically impacted by an extreme space weather event to the point of potential collapse. That's the main federal government concern there. Satellites, operating them properly, whether it's satellite communication or the actual physical infrastructure of the satellite, can be damaged by extreme space weather storms. Astronaut health, aviation can be harmed by radiation exposure due to extreme space weather events of a certain type if they're in the right place at the wrong time, if you will. GPS accuracy, which is important to North Dakota. A lot of the combines and things are using precision GPS to navigate and be within accuracy of inches, right, when they're working on their crops. That can be dramatically off the mark when it comes to an extreme space weather event as well. Our products are trying to get more tailored to individual needs. For example, the power grid, eventually we hope to get to a point where we're not doing a planetary geomagnetic forecast, but we can tailor it to, say, the upper Midwest. The Red River Valley area for the high voltage transmission lines coming out of Canada into North Dakota, and give them a sense of what the actual induced current is on those in amounts of volts per kilometer.
So the Space Weather Prediction Center puts these solar storms on a 5-point scale. You can kind of think of it like the hurricane scale from Category 1 to Category 5, where with a minor solar storm, geomagnetic storm, you can have weak power grid fluctuations, whereas when you get up to a G3 strong geomagnetic storm, that can lead to more impacts to our power grid, satellites, and radio frequency communications, all the way up towards the very rare, severe, and extreme geomagnetic storms. And what the Space Weather Prediction Center is doing, they have to communicate with a lot of different entities to prepare for those level of storms, and they only get a few days in advance notice with when the mass is ejected from the sun to when it impacts Earth's magnetic field. So a couple of recent examples of large solar storms. Last year there was a G4 storm that disrupted precision GPS. So in Canada they had to suspend drilling operations because it couldn't be offset with those GPS communications being compromised. Induced currents on power grids in the northern part of the United States. They took action to mitigate any problems. And more recently in December, air traffic control communications was almost impossible in some cases for about 8 minutes when there was a strong solar storm that impacted Earth. So with the Space Weather Prediction Center, they communicate with the Air Force, their core partner, communicate with them every day for observations and other things. NASA, astronaut health with radiation analysis. The power grid, once they hit that G3 strong level, they need to call with coordinators that are in charge of most of North America's power grid. The Space Weather Prediction Center gives them a heads up. Air traffic controllers are also on their short list of who they need to talk to when these events are happening, and even they can talk with FEMA and the National Security Council if it gets to that level. Right now we're actually increasing solar activity into this next solar cycle, and Sean will explain more on that.
We are currently approaching the maximum of solar cycle 25. That's now predicted to be this year at some point between now and October. We'll see if it has to move on into 2025. But either way, that just means we're at the most risk for the more severe and extreme events, especially in the form of these coronal mass ejections and solar flares and radiation storms. But it doesn't just come to an end and then come down. It takes a few years. So all of this year, all of 2025, and even into 2026, we're going to be at the highest risk during the solar cycle for the more severe and extreme events.
So they'll be pretty busy in the coming months and over the next couple of years with that increased solar activity. And as he mentioned in the previous soundbite there, they're trying to tailor their forecast more to all the different impacts that these solar storms have on Earth with the power grid, GPS communications, and the like. So pretty interesting work that happens at that office in Boulder, Colorado, the Space Weather Prediction Center, and we'll continue this series in the coming weeks with other national centers.
Okay, look forward to it.
Yeah.
Thanks, Jacob.